So today's gonna be like solving word problems and just using different ways of solving ratios and rates. But I just want to say before we get started, I took a look at the entire schedule, like of what we're gonna learn today, not today, next coming weeks, and I just realized that I learned a lot of those things in fourth, fifth grade as well. Um, it didn't dawn upon me until I really looked at it. That's not in my control, Catherine. They changed it. It's not in my control. So yeah, I didn't know. I didn't realize because I was too busy making these PowerPoints. I didn't realize that a lot of the stuff I've already learned these in fourth, fifth grade. So I will try to make this not boring. If you are bored, I'm sorry. That's just how the schedule is. That's just what the content is in this course. Um, I guess if you're really, really bored, I just do something else while this is going on in the background or something. I don't know, go on your phone or something. If you're actually that bored, there is another solution to this problem. I can't say it outright, otherwise they might get mad at me. It does involve something in the top right corner of your window, but yes. Oh, whoops. So just get a few more minutes. Yeah, I can't open up chat, guys. That's not in my control. I'm sorry. Not in my control.
Is the cloud classroom's control?
Yep. They're basically my boss, even though I'm not getting paid, but basically.
Come on, why can't Cloud Classroom let us talk to each other on chat?
But I'm host. They're gonna change it back anyways. They should be. They should be. Oh yeah, if you're like really, really bored, don't type. Just don't type. Just don't spam, but just don't type. Like I said, there's a really obvious solution if you're super bored. Top right corner. Can't say it outright, but you guys are smart. I think you guys know what the solution is if you're really that bored. Um, so I guess let's just get started. I can't answer that question, Catherine. Can't answer that. Okay. So like I said, today we're going to talk about applications of ratios and rates. And so it's just basically a bunch of word problems, easy stuff, bunch of examples. I can't answer that question. Yeah, I can't answer that, but you guys can figure it out maybe. Okay. So let's start. So the first application, pretty easy. Use the table. You take 2 units. Oh, give me 1 second. Okay. Take 2 units and just multiply everything out. So you can use the multiplication table to find equivalent rates and ratios to just simply solve ratio problems. So if it gives you like one ratio and another ratio, you can use the table to expand it. The key to this is to find patterns. You want to find patterns, and you want to also try to match up ratios when filling out a table. So if you have 2 different tables, you want to see, is there a pattern between these 2? Anything correlate? So you're going to try to look for that. And usually involves multiplication. It can also involve division if the ratio is not in the simplest form. So this is just basically finding equivalent ratios, like I said. Really easy stuff. So here's an example of using a table to compare ratios. And the question is, are the ratios equivalent? So let's say you had a paint store and a clerk, right? And I don't know, they're both mixing paint, red and blue paint, right? And so the paint store has 3 parts red, 8 parts blue, and the clerk has 4 parts red, 7 parts blue. Now are the ratios equivalent? You guys can unmute yourself and answer, or just type. Yep, okay, very good. Yep, they're not equivalent, obviously. 3 8s, 4 7s, obviously not equivalent. Okay. And so let's just fill out this table. So what would go in this one, this little square? If assuming we're multiplying by 2, We'll go on this next one. 6, yeah. Okay. Give me 1 second, guys. Hold on. Okay. We'll multiply 2, yeah, 6/18 or 6/18. Whoa. I wouldn't say that. 6/16. You multiply by 2. Oh yeah, I did. Whoops. Actually, it's not working today, Lero. I'll fix that later, but it's not working. So don't worry about that. Okay, so 6/16. What goes in the next one? If you multiply by 3. Yeah. Okay. 248. Yeah, 9/24. Yeah, so it'd be 9/24. Because this times 3 times 3 is 9. 8 times 3 is 24. So it'd be 9/24. 300 over 800. That's multiplied by 100, but yes. All right, and next one would be multiplied by 4. 3 times 4 is 12. And 8 times 4 is 32. Next one, 1232. And then 1540 is multiplied by 3. 3 times 5 is 40. 8 times 5 is 4. 3 times 5 is 15. 8 times 5 is 40. Okay, let's do the clerk one. So you multiply by 2. Yep. 4 14s. Yeah, 8 14s. There you go. 8 14s. Good. 8 14s multiplied by 3. 4 times 3 is 12. 7 times 3 is 21. Multiplied by 4. 4 times 4 is 16. 7 times 4 is 28. Then multiplied by 5. 4 times 5 is 20. 7 times 4 is, 7 times 5 is 35. It's 20, 35. So you can use the table to find equivalent ratios, and it just makes it easier to visualize because you have your 2 different units right here. So it just makes it a lot easier to see. No, Ferwin, I can't. It's out of my control. I'm sorry. If you keep spamming me though, I will remove you. Unless if you want that, it's a win-win for both of us. You don't waste my time, I don't waste yours. We can do that. Okay. Any questions so far? Any questions? No? Feel free to mute yourselves if you want. Okay. All right, so here's an example, application 1. Complete the table below using ratios. All right, so this is pretty easy stuff. So if 1 inch, in 1 inch, there's 2.54 centimeters, right? So if there's 5.08 centimeters, how many inches is that? Mm-hmm. Mm-hmm. You can round this as 2.5 and this as 5. So, yeah. Mm-hmm. Okay, good. So it's be 2 inches. Very nicely done. So what if you had 4 inches? How many centimeters would that be? And as you can see, you can also use the thing I told you about yesterday. So if you had 2.54 centimeters over 1 inch, and you want to find 4 inches, how many centimeters would that be? So you just multiply this out. So you're left with centimeters. And because I'm too lazy to multiply, you get 10.16. Yeah, there you go. 10.16 centimeters in 4 inches. Right? Okay. How many inches are in 15.24 centimeters? 6. Yeah. Very good. 6. How about 10 inches? How many centimeters? This is really easy. 10 inches. Should just see this right off the bat. Mm-hmm. You might want to check your calculation again, Joseph. Multiply 2.54 by 10. Yeah. Yeah. That is right, Andrew. 120. Zoe, multiply. Yeah, multiply 2.54 by 10. Yeah, that's right. Because you want to do dimensional analysis on this one. Because you want to do 2.4 centimeters, 1 inch. This one, since you're converting from inches to centimeters, you want centimeters on top. Just multiply this out. 10 inches over nothing. So they cancel out. You're close. You're missing a decimal point. Missing one number in a decimal point. Just multiply this out. Just simply move it and you get 25.4 centimeters. And the inches will cancel out. So you're left with centimeters as your unit. Okay. Any questions so far? Okay, let's move on. Number 2, a boat uses 2 gallons of gas to travel 12 miles. Using a table, find out how much gas would it take to travel 48 miles and make a table of equivalent ratios. All right, so let's just go by twos, count by twos, just to make it easier. And so since we want to find 48 miles, we just start. So what goes in this box right here? Not 8 gallons, sorry. Right, yes. Okay, so since this is double, since you double the amount of gas used, then you would double the amount of distance. So it'd be 24, not 24 gallons, no 24 gallons. 24, yeah, 24 what though? This is a rate. Or yeah. Well, this is technically a ratio. So 24 miles. Yeah. MI is miles. So it's 24. What goes in this one? Well, yes, distance, but what distance specifically? There's miles right here. You could say distance is very vague. You know, when you say distance, very vague. So you can say, you have to say specifically. 36, yeah. Job 36, because 12 times 3, 2 times 3, 6. Okay, what goes here in this one? So 12 times 4 is what? Yeah, 48. Yep, 48. What goes in the next one? Yeah, obviously you found the answer. Yeah, but keep going, keep going. 60, yeah, 60. And the next one would be 12 times 6, which is 72. And the next one is 12 times 7, which is what class? Not 100. Not 100, 12 times 7. Because it's 2 times 7 right here. So 12 times 7. 84. Yeah. Okay. Any questions so far? Really easy stuff. Really easy stuff. Okay. All right. Second application, graphing rates and ratios. So, you guys have seen a graph before, right? Yeah, XY coordinate. So you get something like this. That's a bad graph, but have you guys seen something like that before? Yeah. Yeah, that's what I thought. All right, so this is just review. What goes on the horizontal line? What axis? Yeah, but you didn't answer my question, Jenny. What goes on the horizontal line? What axis? Sorry, what axis is it? Good job. And obviously, then that just leaves you with the y-axis on the vertical. So, yeah, good job. I learned that in 4th grade as well. I think 3rd grade actually learned that. So, yeah. Then the a-axis. I don't know about that. I don't know about the a-axis. There's a z-axis though. You guys want to learn about that? The z-axis? is 3 dimensions. So you have 1, 2, 3, x, y, z right here. That gives into vectors and scalars. I don't know if you guys would get that, but hey, vectors and scalars. Okay, so you can use rates and ratios graphically in order to solve problems. And sometimes it might be just easier to graph it out rather than a table, or you can just do it in your head, because doing your head is, when you get older, it's not as easy, guys. Trust me, trust me. All right. Maybe a test might ask you to do so. I don't know, be like, oh, graph the thing, graph this ratio rate. You never know. Obviously, when using a graph, use an XY coordinate plane. The dependent variable goes on the y-axis, and the independent variable goes on the x-axis. Now, you guys know what dependent and independent variables are, right? No? Really? No? Okay, we'll get into that further down the line. Yes, no, okay. Yes, okay. Okay, yeah, we'll get to that further down the line. Obviously, I wouldn't be able to find it that well right now, because a dependent variable is obviously a variable that depends on something, but that's not very helpful. You have to kind of see it. So a dependent variable is a variable that is driven by the other variable. Yes, I do mean xy, but there's also dependent variable, independent variables. That's important in rates and ratios, or rates rather, because if you have miles per hour, like let's say you have miles per hour, I think that's why I put in the example. Let me see. Yeah, more on that in a later lesson. So you should just look for which one isn't dependent on the amount of other, that would be independent variable. So just know for now, dependent variable is y-axis, independent variable is x-axis. For example, so a baker takes 8 cups of flour to create a dozen donuts, right? Now, don't treat a dozen donuts as 12 donuts. Treat that as like a one-time thing. So 8 to 1, right? 1 dozen. So which variable would depend on which? You love donuts. That's good to know, Andrew. It's good to know. 12, the dozen? So what do you mean? Expand on that. So which variable? So if I require 8 cups of flour to create 1 dozen, which one would depend on which? Can you ask the baker to give me the donuts? Well, if this baker exists, maybe. Doesn't? Why? Why? The cups? Explain your reasoning. Does he exist? Maybe. Maybe. The cups. Donuts depend on flour. I guess you could see it that way. Not really, not necessarily. Because the cups help make donuts. No flour, no donut. No donuts, no donuts. No donut. No yums. All right, stay focused, guys. Okay. So I'm getting a lot of mixed answers. I'm getting a lot of mixed answers. Dozen donuts. But what depends on which, though? The donuts depend on flour. I would say the other way around. The amount of donuts, I mean, the amount of cups of flour depends on the dozen donuts. Yes. So that's because you can choose however many ways, not ways, however many dozen donuts you want to make, right? It doesn't matter. Like you could just, as independent, it doesn't depend on anything, right? But then how many you choose, the donuts depend on flour because the cups help make donuts. Yeah. I depend on the donut. Okay, let's stay focused. So the dozen donuts are the independent variable because it doesn't depend on anything. You can choose however many dozen donuts you want, right? It wouldn't change a thing. Now, how many cups of flour you would use would depend on how many dozen donuts you want to make, right? And so the dozen donuts would go on the x-axis and the cups of flour would go on the y-axis, right? Any questions so far? No? No one what? What are you trying to say, Jenny? No one. You have one question, or why you type one out? No response. Do we get to eat the donuts? Uh, well, in your mind, yes. In your head. There are no donuts here though. Good. Yeah. I haven't had donut in so long, especially since Corona hit. Oh my God, it's been so long since I've had donuts. Oh man. Okay, moving on. And obviously it's your XY coordinate. You guys know your quadrants, right? Everyone knows your quadrants. Okay. What quadrant is this one, the top right corner? This one. Which quadrant is this? You guys know your quadrants? That's right, Jenny. I'm making you hungry. I'm sorry. Positive. Yes, Catherine. That is true, but that's not the quadrant. Okay, you don't know Zoe? Okay. All right. So this is the first quadrant. We write it in Roman numerals I. First quadrant. Ooh. First quadrant, and obviously has positive x values and has positive y values. The first quadrant, right? What is this quadrant? The one to the left. This is pretty easy, because if this is 1, then this must be, yeah, this must be 2. So this is quadrant 2, right? Roman numerals. You don't know that? Okay, it's okay. So this is quadrant 1. Top right is quadrant 1. Top left is quadrant 2, and it goes in a counterclockwise. The Boston cross we do. I think traditionally how I learned it was this way, counterclockwise direction. That is a good donut, Andrew. Pretty good. Yeah, that's how I learned it. Okay, and in quadrant 2, you're gonna have negative x values, positive y values, right? And this one would be quadrant 3. So 1, 2, 3. Both negative x values and negative y values. And this is quadrant 4, IV. Yep. Positive x values, negative y values. There you go. So yeah, you guys know quadrants. Just a quick review if you didn't know. So quadrant 1, top right corner, quadrant 2, 3, 4. That's how I learned it, at least. I'm gonna be honest. Later on in math, you really don't need to know what the quadrants are. Like quadrant 1, quadrant 2, you don't need to know that. But I guess this is just part of it. True. Okay. So here's an example. So Jesse and his family are traveling to LA, which is 250 miles away. His family has driven 500 miles in 10 hours. Using a graph, find out how long will it take for his family to reach LA. So in this case, we're trying to find out how long it'll take for Jesse to travel 250 miles. Yeah, that's pretty obvious, but we'll do it with using a graph. You can do this in your head. I make these things easy. So independent variable in this case is hours, and the dependent variable is miles, because the amount of miles you travel depends on how many hours you traveled for. Yes, 5 hours. Yes, you guys got it. Good job. Yes. But yes, so the independent variable is hours. Usually, okay, rule of thumb. Usually when you have a rate with time, like miles per hour, kilometers per hour, inches per second, something like that, usually time is 99.99999% going to be independent variable, right? Because time is also usually an experiment, like in a science experiment, you're usually manipulating time. You guys know what manipulating means? I think you guys know what it means. Okay, manipulating means you're changing it around, you're using time to get your results. So usually in most cases, independent variable will be time, a rate with a distance, maybe a distance, it could be like a, I don't know, amount of things you make, could be anything. But time is usually going to be independent variable, and the other one's going to be dependent variable. All right, so let's graph it. So we already established that the independent variable is going to be time, so hours. So would that go on the x-axis or the y-axis? What do you guys think? You don't know? Remember what I said, rule of thumb, independent variable, x-axis, dependent variable, y-axis. If time is the independent variable, which axis would that go on? X-axis, yeah. Yeah. Yep, good job, x-axis, yep. So hours would go on your x-axis. You want to label your x-axis into whatever units you want to use. In this case, we're using hours. And so that leaves you with miles on the y-axis because it's the dependent variable. So miles will go on the y-axis. And so I scale it up. Notice I scale it by 50s because, why do you guys think I scale it by 50s actually? The answer is pretty easy. If you do 500 miles in 10 hours, why do you think I scaled this up by 50s? Think about the unit rate. Think about the unit rate. What is unit rate, guys? Or maybe I didn't explain that well to yesterday. So you're 500 miles in 10 hours, right? You don't need 500 on it. Because the miles in the 50s and 10 and 5. Yeah, you don't need 500. That's not, yeah. Unit rate is 1 hour per 50 miles. Yep. So if the unit rate is 1 hour per 50 miles, wouldn't it make sense just to scale it by 50 every x coordinate? Every one? Because obviously you're going to scale it by 1 hour here, right? So it would also make sense to scale it by 50 for every grid right here. Because 500 over 2. Where'd you get the 2 from? Oh, I see. Graphing by 50 is from graphing for 1. Yes, you're right, Andrew. Yes. But why 50 though? And obviously because the unit rate. So yes. So you just scale by 50, 50, 100, 150, 200, 250, 300, blah, blah, blah. 350, 400. Just gonna erase all that. Okay. And so you obviously scale your hours just by 1 because you know your unit rate. And so where would the first point go? This is really easy. Where would the first point go? Give me the xy coordinate for the first point. Starting on x, if x is 1, what would your y value be? Jumping the gun there, Julie. Jumping the gun. Yep, 150. Good. So 150 right here. I mark it on the grid, not grid, the coordinate plane. Drink some water. Hold on. Yeah, you could do a proportion as well, Jenny. Good. But the question asks you to graph it. So that is out of the question. All right, next one. If x was 2, what would your y be? Capital D colon. Yeah, if x was 2, what would your y be, guys? Mm-hmm. Yep. 100. And if x was 3, your y would be 150 because you're just adding 50. If your x was 4, 200, 50 times 4. X was 5, 250, 50 times 5 is 250. If x was 6, then your y would be 300. And that's it, you graphed it. And obviously, answering the question, Justin's family traveling to Los Angeles is 250 miles away. Find out how long it'll take for his family to reach Los Angeles. Well, you just look for the 250 here and see that it takes 5 hours to reach the 250 miles. And you can also draw a straight line. Do you guys know what a slope is on a line? Do you guys know what slope is? No? Okay. That's a little advanced. You learned that in middle school. So I know. Hey, but you guys seem to know all this stuff already. So the earlier, maybe if you guys are really bored, I can expose you to like more advanced stuff, so you guys aren't that bored. I don't know. What do you guys think? And plus, the earlier you get exposed to it, it might be easier. You're not bored? Oh, thank you, Zoe. Thank you. You know what slope is, Jingwen? Okay. So slope is just big brain. So slope is just the value of rise over run. That's the most formal definition of slope. So if you take these 2 points right here, right? So you take 150 and you take, so this point and this point, 100, right? The slope There's a slope formula. So slope is m is equal to y2 minus y1 over x2 minus x1, right? So let's say this is your y2 and this is your y1. So 100 is your y2, your 50 is your y1. This is your x2, your 2 is your x2, and your 1 is your x1, right? So if you calculate out the slope, you plug this in, 100 minus 50 over 2 minus 1, right? Notice how the coordinate points line up? Then your slope would just be 50 over 1, which is 50. So your slope is 50, which is also your unit rate. I don't know if we're going to have time for that, Lyra, but we'll see. Maybe. Plus, I don't know if they all can access it. We'll see. I'll tell you why later, but yeah. So slope is 50. So this is a slope formula, and slope is the rise over run, right? So you rise 50, you rise up 50, and then run. Run is horizontal distance traveled, rise is vertical distance traveled. Whoops, I did not mean to do that. Press my button. So your rise is 50 units, right? Because 100 minus 50 is 50, and your run is 1 unit. So 1 is a 50 right here. So rise over run, 50 over 1 is your slope. So just getting exposed to that right now. That is your slope. And I'll talk about slope intercept form maybe later. Just a really quick pointer. Y equals mx plus b. You guys don't have to know this obviously right now, but earlier you're exposed to this, maybe it might be better. All right, let's move on. Cool. Yeah. All right. A Guinness World Record holder, Joey Chestnut, can eat up to 75 hot dogs in 50 minutes. That's insane, right? 75 hot dogs in 50 minutes? I can eat like 4 hot dogs in 5 minutes if I'm really hungry, but then I'll just be like gassed after that. Like I just cannot go any further, right? I just can't. But that's only if I'm really hungry. Anyways, you get 1 in an hour. Ugh. Well, light eaters, huh? You ate a 6-pound pizza? Who ate a 6-pound pizza? And why is pizza supposed to be a pizza? Blech. Yeah, well, that's only if I'm really hungry though. Like if I'm absolutely sorry. What does insane right mean? Insane means like that's pretty cool. Like pretty wow. Let's just wow. Insane? Something's insane. Something's crazy, right? It's kind of crazy. Hot dogs are. Oh, okay. Well, good job, Andrew. You're jumping the gun here. Yes, hot dogs are dependent. So what unit goes on the x-axis and what unit goes on the y-axis, and graph the following situation. So yes, what Andrew said, hot dogs are indeed dependent. So I'm gonna write that down. Hot dogs. Wait, that's dependent. Wrong one. Sorry. Hot dogs on the y-axis. Yep. So hot dogs. And so your minutes, which is always your time, is independent. So minutes. MIN for minutes. Yep, that's right, Zoe. Yep, minutes is X. Yep, goes on the X side. All right, so let's graph it. So how do you guys want to scale it? How would you guys want to scale it? By 5? Ooh. You don't know? Well, you could just go simple. You can just scale it by 75 hot dogs in the y-axis because it's 75 and 50 minutes. And just do 50s right here. All right, these are pretty easy. 15 seconds. That could work, but then you would get decimals. And decimals are not fun to graph. You could, but 15 seconds is not fun. That is, because then you do 15, 30, 45, 60 minute, or not seconds, sorry, 15 minutes. Like percentage is better? What do you mean by that? Like percentage is better? Anyways, okay, stay focused. 2 x 3, 4, not by seconds, by something. Oh, okay. Well, we have minutes as our units. Okay, so let's just scale it simply by 75. So 75. All right, what goes here, guys? 75 times 2. Really fast. 75 times 2. 150. Nice. 150. I'll do this one for 225. What would be this one?
I like you watching a
times
lot
4.
here.
300. Yep. This one's really easy. 375. I'll do it for you. And next one, last one. We'll do this last one. We'll go up here. That should be a 7. 450. Good job. There you go. Nice job, guys. Nicely done. All right. How do you guys, so let's scale the minutes. 50, 100, I'll do 200 right here, and 300 right here. You guys know why I skipped these two right here, right? It's pretty obvious. Skip these two because those are, you treat them as 50. All right, so what would be your first point? Well, actually, we already know our first point. It's 50, 75, right? Because 50 minutes, 75 hot dogs. Right here, right? So that's our first point. What would be our second point? What are the coordinates for our second point, rather? No? You don't know, Jenny? Multiply it by 2. Multiply these two by 2. Yeah, 100. The x and y coordinates. Multiply them by 2 and you get your second point. Because this is just a multiply by 2. It times 2. Yeah, 100, 150. Yeah. Just multiply by 2. 100, 150. Yep, 100, 150. Yeah. Nicely done, nicely done. All right, what about the 200? Let's just skip straight to 200. What would be your next point? It's pretty obvious to see, excuse me, based on how I scaled it. But what would be, what if you had 200? How many hot dogs? Assuming that Joey Chestnut doesn't slow down, how many hot dogs would he eat in 200 minutes? Because this guy is insane. This guy's crazy. Well, it's 50 times 4, right? So you do 74 times 4, or 75 times 4, sorry. So how many hot dogs would that be? Pointing at it right here, guys. How many hot dogs do you eat in 24 hours? Probably a lot. He's pretty big. He's a big boy.
Big boy.
300 hot dogs. Very good, Donald. Very good. 300 hot dogs. And for 300 minutes, how many hot dogs could he eat theoretically? Well, it's 50 to 300. To get to from 50 to 300, you don't multiply by 6, right? So 75 times 6. 6, 3, 4, 2, 450, right? So 450 hot dogs in 300 minutes, right? And I just make a line. Whee, that's not a perfect line, but you get the idea. So what would you be your slope? What would be your slope? Let's calculate it. So m equals y2 minus y1 over x2 minus x1. Right, so this is x1, this is y1. This one would be y2, x1, or x2, sorry, x2. Right, so let's calculate it. M equals 150 minus 75 over 100 minus 50. Right? What would that be, guys? Let me erase this one. So 150 minus 75 is 75. 100 minus 50 is 50. If you simplify this out, you'll get, what'd you get? 5, 1, 2, 65, 15, 5, 7, 3 halves. 3 halves. Oh my God, I didn't see that. I can't believe I didn't see that. So your slope is 3 halves. Yeah, there you go. Slope is 3 halves. That is the slope of this line right here. Assuming this was a perfect line, that is the slope of this line. Let me highlight it. That would be your slope. That is not perfect. Okay, that would be your slope. All right. Any questions? No. Okay. All right. Third application, part to whole, part to part, and part to part whole ratios. That sounded like a lot. It's not that hard. Trust me. You already did this yesterday. So most of the ratios we have done are part to part ratios. So if I had, say, 2 red squares and this is class N 15. Yeah, I think we'll get there soon. And 3 blue squares. Yeah, this is class N soon. 3 blue squares. Right? So this is a part to part. What's the ratio from blue to red? Would be 3 to 2, right? So that's the part, one part of it, and the second part, right? So examples of 3 apples, 4 bananas. Ratio of apples to bananas would be 3 apples to 4 bananas. However, both the apples and bananas are just parts of the total amount of fruits. So there's 7 total amount of fruits in total. 3 plus 4, 7. So sometimes ratios will be represented in a part-to-part format, but we'll ask or use for a ratio in a part-to-whole format. It requires you to count up all the parts, like I said, so count up all the fruit and compare the parts of the total into another part. So let's go back to the original example. Okay, remember, ratio is comparison between 2 quantities, so it's still valid, still as a ratio. What is going on over there, Fairwind? Oh my God. In other cases, you'll have sometimes be given a ratio in a part-to-part format, and we'll have to convert that to a part-to-whole. I don't know if I included an example for that, but I don't think you'll need to know that. Okay, so let's try this. Image below, there's a ratio of 3 blue squares to 1 yellow square, right? So there's 4 total squares. What's the ratio of blue squares to all squares? And what's the ratio of yellow squares to all squares? What are their percentages? It's pretty easy, right? So let's try the blue squares. So there's 4 total squares, and there's 3 blue squares, right? The ratio of blue squares would just be 3. Can't really see that. 3 to all 4, right? 3 to 4, right? And same thing for the yellow squares. You have 3 to 4. Yellow squares would be 1 to 4 because there's 1 yellow square for total squares. Percentages, 3 to 4 is 75% because it's 3/4, and 1 to 4 is 25%. You say 25% yellow squares, 75% blue squares. Pretty simple, pretty easy. Okay, this one, there are 5 pups, just call them dogs, I guess. 2 are boys, 3 are girls. The ratio of boys to girls is, well, there's 2 boys, 3 girls. So the ratio of boys to girls is 2 to 3, or 2/3. The ratio of girls to boys was 3 girls, 2 boys. You just flip them around, 3 to 2. Yep. Very good. Ratio of boys to all pups. Well, there's 5 total pups or dogs, and there's 2 boys. So that'd be, you're comparing boys to all pups. So that'd be 2 to 5. Yep. And girls to all pups. Well, there's 3 girls, 5 pups, 3 to 5. Very nice. Good job, guys. All right. I recall that unit rate that makes comparison only one singular unit. So miles per hour, miles per 1 hour. If you've already done this, you use unit rates to make comparisons and solve problems to do them. That's how we learn proportions, how to apply them. Now, I think you guys know what proportions are, so you're not learning, reviewing. A proportion is a mathematical statement that says that 2 fractions are equal. In this case, ratio rates, same thing. And solving proportion, where 2 fractions are equal, usually know 3 out of the 4 numbers and trying to solve for the 4th number, right? So as an example, 10/20 is equal to something over 30, right? What do you guys think this is? Yes, I know you know. I said treat this as review. And maybe some people don't know. I don't know. Some people don't know. 15? Yeah, that's pretty easy. Yep. You guys know the strat, the trick to doing it? Do a cross multiply right here. Cross multiply. You guys know the trick? 20? It will not be 20 because this is 1/2, Zoe. And so you want something, what over 30 would make 1/2? So we'll see. Okay, so you multiply, cross multiply, and then you divide by the 3rd number you didn't use. 20x equals 30. Yep, 300. Yep. That's exactly what you do. So this would, question mark would be 15. All right. A skydiver falls 144 feet in 3 seconds. How fast does a skydiver dive during this time? Well, you can set up a proportion doing this, or you can just simply divide it out. And the second question, Mel fills up the tanks with 6 gallons of gasoline, premium gas, posh guy. He pays the total cost of $26.58. How much does it cost to fill up 1 gallon? And how much does it cost to fill 20 gallons? right? 48 feet per 1 second. Yeah, you guys got that. Now I'll do the second one. What the second one? So 6 gallons premium gasoline. Total cost is $26.58, right? So how much does it cost to fill up 1 gallon? Be 48 feet. 48 feet, Joseph. 48. 1.43. Mm-hmm. Yep. Okay. And so 4.43 per gallon. How much would it take for 20 gallons? Um, that's how'd you get that, Zoe? That's not the right answer. I'm sorry, but yeah. That's the right answer, Catherine. Mm-hmm. Yeah. Right. Yep. That's how you set it up, Andrew. That should be right. Wait. No, 6 gallons equals the price of 1 gallon times. Wait. Where'd you get the times 20? Because you do 1 gallon equals 26.58 over 6. But then you need a x over 1 gallon. Go for it today. Yep, that's right, Zoe. Yep. So it's $4.43 per gallon. Not quite, Zoe. You would multiply if it's $4.43 per gallon. How much does it cost to fill 20 gallons? You multiply by 20. 4.43 by 20. Yeah, that's right, Donald. Yeah. Okay. Let me do this real quick. All right, so we established that's $4.43 per gallon, right? Donut, okay. So you can set up a portion, right? X dollars for 20 gallons. And so you just simply multiply by 20, divide by 1, it's the same number. So 4.43 times 20 would be 88.6. Yep, okay. Let's move on. So here are the answers. Oh, third one. We can skip this one. Skip this one for now. All right, 48 feet per second, 443, 88, 60. 52 balloons, you just divide 728 by 14 to get 52. I'll do that real quick. 5 times 4 is 20, so 0, 70, 72, 28, 2, 52. Right? Last one, this is new stuff. So in a right triangle, definition of sine, I know this is a little advanced stuff, is the ratio between the opposite side of an angle and the triangle's hypotenuse. So you guys know what a right triangle is? You guys know what a right triangle? You guys know what that is? Yep, yes, right triangle. It's a triangle with a 90-degree angle. That's a right triangle. That's a right triangle. Yeah, it's 90 degrees, yep. Okay, you guys know, so let's say I had triangle A, B, C, right? And it's 90-degree angle, and these two are angles. So let's say I had angle D and angle E, right? So the definition of sine is the ratio of the opposite side between the opposite side. You guys don't know sine. You guys don't learn that until middle school. Don't worry about it. And triangle's hypotenuse. So hypotenuse is the longest side. So C is always your longest side. This is diagonal. Yeah, C is the longest. Good job, Zoe. Yep. C is the longest side, right? So let's say we look at angle D. What would be the opposite side of angle D? Would it be A or B? Because you know C is your hypotenuse. Yes, that's Pythagorean theorem, Jungwon. Yes. Yes, A. That's correct. Yes. A is your opposite side from angle D. So sine, not sin, it's sine D equals A over C. That's the definition of sine, right? So make this easy. So you have a 3, 4, 5 triangle. These are Pythagorean triples. That's not Pythagorean triple. You shouldn't know that off the top of your head. And so We have 3, 4, 5, this triangle, this right triangle. I'll put this. And we're trying to find this missing side of this other right triangle, right? And here is your angle over here. So find the missing side in the second right triangle using the definition of sine. You can only use the definition of sine because you have to make a proportion. Yeah. 6 is not the question mark. 6 is this side right here. So how would you guys set this up? If you know that sine of this angle right here is opposite of our hypotenuse, right? 3/5, right? So that means for this angle, the opposite, sorry, that's adjacent, that's tangent, over hypotenuse be question mark over 7.5, right? 5.5, 4.5, make your, yeah, 4.5. Not 7, Zoe, not 7. So then you just simply solve this proportion. You just multiply this out, and then you divide this. Really easy. So after cross multiplying, you get 4.5. So let's do it. 7.5 times 3 is 22.5. Then 5 divided by 22.5, 4, 2.5, 4.5. So your missing side is 4.5. But it looks like, aren't these similar triangles? Yes, they are similar triangles, yes. I made them that way purpose. 4.5 over 7.5? Yeah, that's right. But if we just want to find the missing side. All right, I think that's the lesson for today. Unless you guys want to learn cosine and tangent. How did I get that? Okay. So, hold on. Yes, you learn cosine and tangent. Okay. Wait, what grade are you in, Jingwen? How did I get that? So Joseph, how did I get that? So basically, using the definition of sine, it's the opposite side, right? It's a ratio between the opposite side of an angle and a triangle's hypotenuse, right? So if this was your angle right here, let me erase all this actually. Yeah, okay. If this was your angle right here, then opposite side would be question mark, right? So the ratio between the opposite side, and then your hypotenuse would be 7.5 because that's the longest side of a right triangle. It's always the diagonal. Always the diagonal. Okay? So your proportion would be question mark over 7.5. Now, because these two are similar triangles, you know tangent already? Nice. So these two are similar triangles, right? You can also make this proportion the same. So if you use this angle, the opposite side would be 3. So 3 goes on top because opposite over hypotenuse. And your 5 would be hypotenuse. So 3 over 5, right? And then you just simply solve for the question mark. So you do cross multiply, 7.5 times 3. Let's do it real quick. 5, 1, 3 times 7 is 21, so 22.5. And then you divide by the third number. So 5, 22.5, 4, 22.5, So you get 4.5 as your question mark. You get that? Are you good, Joseph? Yes? You sure? Okay. I know I'm going really fast, but since you guys seem to know a lot of this stuff already, it's yeah, it's so crazy. All right, while we're here, if you want to stay, learn tangent, cosine, really fast. It's really, really fast. You can do it. But this is the last thingy. It's the last one. Here, if you guys want to stay for this, you guys can leave the meeting. It's 6 o'clock right now, 5:59. You guys can leave the meeting. If you want to stay for a little extra stuff, sine and cosine tangent. Yep, you can go. Yep. Bye, guys. I'll see you guys next week. Okay. That's good. For donuts. Yeah. Let's see. Okay. So if you guys want to stay, because you guys are smart cookies, triangle ABC, right? Triangle ABC, right? Yummy. Yep. And so you have angle, let's call this theta. This variable is called theta, right? This is called theta right here. It looks like that. Looks kind of weird. I know it's a Greek symbol. Looks kind of weird. So at angle theta. Now, we already established sine is equal to opposite over hypotenuse, right? So C is your hypotenuse, and A would be opposite the theta. Big brains, true. So cosine, the definition of cosine is the adjacent. Adjacent means the one next to. So in this case, the adjacent side to theta, angle theta, is side B. That's your adjacent side divided by the hypotenuse. So C, right here, right? And tangent, can't it be C? Yeah, your hypotenuse is C, yes. I'm just not plugging in the variables yet. Then tangent, the definition of tangent is adjacent over, no, sorry, opposite over adjacent, sorry. No. Okay, let's try that again, okay. A, B, C, angle theta, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? So they're all the same. So this is important, something called trigonometry, which uses right triangles. Pretend this is a right triangle. This is badly drawn. I just rushed it. How do you get sine, cosine, tangent? That's just what they're shorthand called. So when you write them short, the full names is sine, S-I-N-E, sine, cosine, S-I-N-E, cosine, co plus sine, and then this is tangent, T-A-N-G-E-N-T, tangent. They just call it tan, cos, cos, however you want to pronounce it, and pronounce the sine. Don't pronounce the sin. It's not sin, guys. Calm down. So that's just how you shorthand them. And these are the definitions based on the ratio of the sides in a right triangle. All right. So if you wanted to find sine theta, because this involves angles. So the sine of an angle, the cosine of an angle equals the adjacent side to the angle of the hypotenuse, tangent of an angle, opposite side to the adjacent side. So sine theta, well, if theta is this angle, you know the opposite side is A, sine theta, so A goes on top because the opposite side, and the C is always your hypotenuse. So sine theta equals A over C, right? Cosine theta, well, you have adjacent means next to, so what's next to theta? Well, side B. So B and C is always your hypotenuse, so B over C is cosine theta, right? Last one, tangent theta is the zero, this is called theta, I forgot to mention, theta, so theta, T-H-E-T-A, it's called theta. I don't know what you guys use in China. In the US, we use theta for angles most of the time. Maybe you guys use something else, I don't know. You call this X, you call this angle X, you can call this angle Y, it doesn't matter. Just call it some angle something. Okay, so backwards, tangent theta is the opposite side to the theta is A over the adjacent side is B. So that's the definition using a right triangle ABC, the definition of sine, cosine, and tangent. You guys get that? I don't know if you guys get that. You don't have to know this. This is pretty advanced stuff. You guys don't have to know this. But it would be good to get exposed to it sooner. So SAT has same question. Aren't you in 4th grade? Why are you looking at your SATs already? Oh my God. What does the theta do? The theta doesn't do anything. The theta is just a variable. Oh, you have a sister. Ah, yes, it is on the SAT, yes. The theta is just a variable for your angle. You can call this angle D, call it angle X, angle Y. Most commonly, we call it theta. That's the most commonly how we call it, angle theta. And you guys know pi? You guys know what pi? So it is angle, yes, it is angle. Okay, real quick, last one, we can go. Do you guys know pi? 3.14, yeah, approximately 3.14 0.14159. I want to say 126. I forgot. 26. Yeah, there you go. 26. Yep. Okay. So why am I talking about pi? Well, pi is also related to these things right here as well. So pi is also related to these things right here. I won't tell you necessarily why, but pi is related because pi tasty. True. Pi is tasty. So you get sine pi, if my brain doesn't fail me, is 0. Cosine pi, -1. Then tangent of pi. How? I won't tell you because that's too advanced. You probably won't get it, and it takes a long time to explain actually, because then you need to build up on stuff. Yeah, it's something called the unit circle, and yeah. Honestly, I could do another 1-hour course about the unit circle and everything. Yeah, pi is 1/8. Yes, from radians to degrees. Yes, pi is 180 degrees. Yep. So then you get tangent pi. Tangent pi should be undefined because tangent is sine over cosine. Or no, 0. I think my brain's failing me. Tangent pi. Hold on. Yeah, it's 0. 0. Undefined is whenever you divide by 0. You cannot divide anything by 0 because it doesn't make sense. So 7 divided by 0, undefined. UND. Undefined. The answer does not exist. We're not smart enough to know what the answer is. Or we just straight up, the thing just doesn't, dividing by 0 is bad. Don't ever divide by 0. All right, that's enough for the lesson today, guys. I hope you enjoyed that last bit. If it didn't blow up your brain too much, right, you guys are free to go. I'll see you guys next week. If anyone has any questions, I will stay for a little bit more. Not 0.7, it's 7 divided by 0. So 7/0. Why can't you do that? Because, okay, so think about it. So division is multiplication backwards, right? You have to be able to do it backwards, right? So if you had 4 divided by 2 equals 2, right? That's because 2 times 2 equals 4. You go backwards, you're able to do it backwards, right? It could be, yes, but that's one of the possible answers. There's infinite amount of answers when you divide by 0. Okay, so let me share my screen again. Okay. So let's say you had 4 divided by 2, right? And that equals 2. Hold on. Yep, that equals 2. But then when you do division, you have to be able to go backwards. That's because 2 times 2 equals 4. Notice that I went backwards. 2 times 2 equals 4, right? Now, if you did 4 divided by 0 equals question mark, you could put any number. No number exists because anything times 0, x times, the dot is another way to say times. X is a variable. X times 0 will never ever equal 4. That's why the answer is undefined. That's why you cannot divide by 0. Anything times 0 will never ever equal to whatever number you have. Now, there's the case for 0 divided by 0. 0 divided by 0 is technically this answer. Actually, no, it's all numbers. It's not even all real numbers, plus imaginary. That's a little advanced stuff. You guys don't need to know, but think about it. 0 divided by 0, you could put 4. 4 times 0 is 0. 0 divided by 0, you could put 3. You put 2, 1, -4 million, and it would give you the same result. So 0 divided by 0 is a little special. But you can't divide by 0 because you're not able to go backwards and get your same answer. That's why you can't divide by 0. I hope that made it clear. This is called all real numbers. You don't need to know this. Don't. Just forget I ever wrote this. Forget I ever wrote this. Because anything times 0 is 0. I won't forget this. Yes, that's why you cannot. It's one of the fundamental rules of math. You cannot ever divide by 0. If you ever divide by 0, the world's going to break. The world's going to fall apart. The world's going to end. You're done for. So let's say, never divide by 0. And if you ever do divide by 0, call it UND, undefined, because you don't know the answer. No one knows the answer. Well, we still got a lot of people still here. You guys have questions, or are you guys just curious about dividing by 0 and everything? So honestly, it's not that interesting. Okay, anyone still have questions about the stuff we talked about today? All this stuff? The ratios thingies? Keep it all. Anyone have questions? Stop sharing. Nope. Okay, I'll end the meeting. Hope you guys had somewhat fun. Maybe your brains are a little fried. I don't know. Hope you guys had a good one. I will see you guys next week. I'm gonna end the meeting. Bye, guys.